an extra $1.
I'll pay you.
It's so much time. Do you guys have a study hall?
Yeah.
Because if somebody would TA for me, it's actually not a ton of time to hit print. That's actually not hard to hit print.
But like staples it together.
Yeah, I don't want to, like, I spent hours and hours and hours doing this, like, every year. And then the realization was only the people that are essentially at the top really get it done anyways. And they're the ones that don't actually need that much more help anyways. And then the bottom people that really need the help, I do all this work for, and then they don't turn in anything, or they just come in here the last day and they're just simply copying down all the answers. When I was doing the extra credit, I was like, what am I doing here? This is not helpful. Now, having blank tests, I can understand that would be helpful, but it's like, that's a ton of work for me. Just, I'm not going to do it anymore. But part of that is I have nobody to, like, staple, like, hundreds of tests together. So if somebody wanted to take that on and say, hey, on this day, this time, I can just go to print, and then you go down there and stand at the printer, wait for them all, and then staple,
Yeah.
staple,
We could do that.
organize, and hand out. That would, I'd be willing to do that for you.
We could do like one test per day. Like,
Well, it's not too bad once you have it, but it does take a while to print off hundreds and hundreds of sheets of paper. And I never wanted to clog the printer, so I was doing it after school, make sure I wasn't clogging the printer, and
Yeah. And then
So, but if there's a time where there's nobody like printing, that's a nice time. And then if there's a study hall time, you just get a stack of papers and then you can staple them all and pass them out. That'd be fine with me.
Can we just do it for our class then?
Yeah.
Okay.
Freshmen don't know the difference, nor sophomores, because I didn't do it last year.
Okay.
In terms of algebra and geometry, they don't know anything.
They don't deserve it.
Well, I didn't say that, I just said they don't know.
but,
So this class, maybe pre-calc wants it, so they could do it. Or something, but yeah. So we can organize who wants which tests, and then print them off. So I'd be willing to do that if you guys are willing to organize them and staple them.
and then we have a pizza party after the final.
Pizza party after the final.
Yeah.
It'll be like on the last day of school,
Oh.
and we won't be here.
That's summer.
Oh yeah, you're right.
But summertime, you guys can have a pizza
No.
party. Absolutely, organize the pizza party.
Does anybody have a cabin?
Does
Berg.
anybody have a cabin?
Yeah, we can do like a little party. Oh,
Everything has to be like. Yeah. Okay. Here we go. 12/7. So yeah, we are down to the final days of school. We don't have many days left. We do have at least probably 3 tests, probably not more. We'll have chapter 12, and then chapter 16, and then chapter 15, and then that's probably it. If there is any time, I do like to hit a little bit of chapter 13, but maybe only an MCA essentially gets hit up on that, typically. So, just keep that in mind. There's just a little bit of a grind left, and 16 usually provides a lot of relief, usually. Although we do find miraculous ways to make things hard, don't we? Which is just the way life is too. Sometimes it's just hard. That's the way it is. Alright, so law of signs, sign A, sign B, sign C, all over A, B, and C. People generally like this one. You guys have seen this before from geometry. Hopefully you remember a little bit of it. This is again with non-right triangles. However, law of signs, you can get away with right triangles and using law of signs. That is because on the unit circle, which you've memorized, right, and or your calculator, which would be fine, if you do the sine of 90 degrees, everybody knows that the sine of 90 is 1. Very good. Yes. But 1/2 is the unit circle value. Very good. You're in the ballpark. So that's why when you do sine of 90 in the law of sines, you'd still get the number and it actually works. So you'd be fine. You can do it. I don't ever like teach it because I just think right triangles, SOHCAHTOA or Pi-Phi. And that's actually the easiest. But some people do the law of sines. The issue is that if you did, so that's its own separate entity. If you did cosine of 90, like for the law of cosines, everybody knows that the law of cosines, not the law of cosines, the cosine of 90 is, everybody knows it is
1/2.
0. Good.
Which one is 1/2?
It's right up there, you know. Can you see it right up there?
Wait, is cosine always the first one of the...
Cosine is x over r. There you go, right there. Cosine is x over r, so it's the x value right here.
So it's always...
Sine is the y value, right? So it's right.
And tangent is the little...
Tangent is y over x, so it'd be like 1 over 0, which would be undefined. So tangent at 90 is undefined.
Wait, I didn't know.
Now, so tangent's not on, tangent isn't on the unit circle, but it is, but you can find it simply by going y over x. That's what tangent is, because it's just actually sine over cosine. So,
Oh, so it's like sine, cosine, tangent.
oh,
It's like...
wow. And a dance move if you will.
I'm thinking like that side, instead of going like sine, cosine, sine, cosine. Yeah.
So yeah, and the unit circle that goes cosine comma sine, because cosine is x over r, sine is y over r. So that being said, you could do law of sines for a right triangle, but I don't teach that, but you can get away with it in general. Also, this law of sines is the ambiguous case, and I say ambiguous because there are certain parts of the law of sines that you could have two different answers. And you say, well, how could I have two different answers? Well, the issue is that with a brief, and I don't make people memorize this, but with sine, you know, sine of 30 degrees, everybody knows what the sine of 30 is.
1/2.
Yeah, hey, there you go. So the sine of 30 is going to be 1/2, right? Well, we also know that the sine of 150 is also what? 1/2. And so they're actually, if you have something like this where you have sine of an angle measure and it's unknown and you're like, it's equal to 1/2, we would say, well, that could be a 30 degree or it could be 150 degrees. We actually don't know. And both of these would fit into a triangle measure, right? You know, so you'd be like, well, do I have a triangle like it's a 30 degree angle, you know, whatever it looks like, something like that? Or do I have a triangle that's a 150 degree angle and, you know, looks something like this? If you only know the ratio is 1/2, you don't know which triangle you're ending up with. And so it's the ambiguous case. Now, there is the process in there. I mean, it's not like extreme. I actually don't know where on 12.8, they actually talk about this. And there's a way you can do it where if this is less than this, and this is greater than this, and this is less than that, then you would do this and this, and then you can land on this. So I don't get into the weeds of that, just a general understanding here. Now, why doesn't it matter for cosine, like the law of cosines? Well, that's because cosine, you know, at 60 degrees, everybody knows what cosine of 60 degrees is. Cosine of 60 is 1/2. But cosine of 60 over here is not 1/2, it's actually a negative 1/2, which therefore that angle measure, right, of 90 plus 30, so the angle measure of 120 could form a triangle, except the ratio would be negative 1/2, and you wouldn't have a negative 1/2 ratio in a triangle that you're solving for like this. So therefore, the other angle that actually would work would be all the way over here, 270 plus 30 at 300 degrees. And does 300 degrees work in a triangle? No, right? What's the max angle in a triangle? Less than 180, right? So you get up to 180, you can't do it. So it has to be less than 180. So it doesn't work for there because that would be a positive 1/2 for cosine. So that's why cosine doesn't have this ambiguous case. Sine does. So sometimes in the answer, you'll see two answers and you're like, wait, what? I just did my calculator and my calculator gave me 30, but the answer is 30 or 150. You're like, what? Well, that's because it's dealing with the ambiguous case of this idea of understanding the unit circle. I don't usually emphasize that or mark people wrong if you know if you put the one answer, because your calculator will always be giving you your one answer. It'll be giving you the 30, It won't be giving you both answers. Some may do that now, I don't know, where you can find both, I'm not sure for that. So, okay, so let's just do a few problems. Let's say you're given C, so this is just solve maybe for, one of the sides, problem number 1, C is 12, okay, angle A is 42 degrees, and then side angle C is 69 degrees, and then side A is equal to unknown, okay? So now, you could draw the picture of this, or you can plug in the law of sines and just see if you have enough information. If you did draw a quick picture of this and said, okay, I have 42 degrees, and then I have, 69 degrees, and then opposite of 42 is A, and this is C, A, opposite of C is 12, and this is B, we'll call it B, and you have an unknown there. So you look at this, what have you been given? You have been given side, angle, angle, or angle, angle, side. So if you're given angle, angle, side, now remember with angle, angle, side, could you find the other angle right there? Yeah, without trigonometry, right? So, but if you're given angle, angle, side, let's see if it works. So when you do the law of sine, you take the sine of an angle, sine of 69 over 12, and then you take the sine of the other angle of 42 over the unknown A. So do you have enough information? You bet. So if you're given angle, angle, side, is that enough information? Yes, it is. Or you could be also given angle, side angle, and that would also be enough information because you could find your third angle. Here, really easy, right? Because when I say it's easy, it's just fractional, proportional work. So you cross multiply. And so you go A times sine of 69 is equal to 12 times the sine of 42. And then you go A is equal to 12 sine of 42 divided by sine of 69. And you just crank that into your calculator, making sure you're in degree mode, which that's all we've been working with, right? And then we make sure we're in degree mode and you hit enter, and it gives you a value. Now, the value, you can make a note if it's opposite of A, which it is, angle A, should it be smaller than C or bigger than C, right? So there's some logical reasoning you can do. And you can say, oh, since A is a smaller angle than C, then side A should be smaller than C. And so what do we end up with?
8.6.
8.6 approximately, okay? Sounds reasonable to me. So there you go. If you are given, let's say B equals, we'll just do B equals 12, C equals 11, so now you're given two sides. If you're given three sides, and that's it, you would maybe make a note that if you're given three sides but no angle measures, law of cosines works, but it wouldn't work here, because if you were given three sides, and you would take, okay, three sides, so I know two of the sides, but I don't know any angles, I'll have two unknown. And so then you couldn't solve. So, but they wouldn't give you that in this section because they are, doing law of sines. Now, what angle measure can they not give you, or if they gave you it, would it be helpful? What? Not the actual angle measure, but is it A, B, or C? Which one, if they gave you a certain angle, A, B, or C, which one would it not be helpful? A, right? Because if they gave you angle A, you would say sine of A over unknown, sine of unknown over known B, you would have two unknowns going. So they won't give you that unless it's some sort of mistake, so they'll give you something like this. Okay, so now that we have that, and then they're going to want you to find angle B. Okay. And you can make a note that angle B should be larger or smaller compared to C based off of the side legs. So you take that and you just plug in and say, okay, sine of angle B, doesn't matter which way you go actually, in terms of C or B first. And then you have sine of 40 over C, which is 11. You could cross multiply, but that would be extra work. I would just multiply by 12 to both sides. And then you have sine of B is equal to 12 times the sine of 40 over 11. And then you do inverse sine of both sides. 12 sine of 40 over 11. You know, yeah, okay, so then we just punch that into the calculator and hit enter and you pop out an answer and the answer is?
44.5.
44.5, okay, so a little bit bigger, sounds good, 44.5 degrees. Now, in this, that would be, actually like the opportunity to understand that that could be the ambiguous case. And again, I wouldn't mark you wrong, but this would be where you'd see two answers in the book and you're like, wait, why are there two answers? Well, remember, 44.5, because that's what your calculator gave you, right? 44.5 degrees is right there, okay? But what other angle measure in a triangle could also equal this? Well, it's just a reference angle, so 44.5. So you would just take 180 minus the 44.5 and it would give you this angle measure right there, and that's the other angle to measure that could work. We don't have enough information to figure out which one it is. And so 180 minus 44.5 would be 135.5, right? And so your answer is going to actually be this and this. But I'm not going to worry about that. Maybe I'd give you a little bonus on a test if that was the case, but then I do that and people actually don't know what they're doing, and they're doing law of cosines, they're writing multiple angles all over the test, and it's like, no, you're just hoping for the best by writing multiple angles, and it's wrong. So again, why wouldn't it work for this one down here, 44.5 degrees? Well, it'd be over 180 degrees. Is that forming a triangle? No. And it would be giving me a negative ratio, which this is not a negative ratio. So, but that you'll see this in the book, and you'll say, wait, why 2? And now you're like, oh yeah, that's why 2, but we'll just stick with the 44.5. Now, if you chose to do 135.5, I wouldn't mark you wrong. You could have both there, or one of them if you could choose either one. So that would be fine as well. All right, so let's just go ahead and take a look at a couple story problems. Page 589, we'll just set a couple of these up. You have 3 through 12 all on these. So again, it's just setting up the triangle, and then in this case, you're most likely going to use law of sines to solve on these story problems. So page 589, and we'll take a look at number whatever. Let's go with number 5. Just set up number 5. Again, try to focus on starting with a really good picture is beneficial with these, and then can yield a point at least to have a good picture with the correct angle measures and a notation of which what you're looking for. So it says a fire is sighted from 2 ranger stations that are 5,000 meters apart. Okay, so if that's the case, it doesn't really matter where you draw the 2 fire stations, the ranger stations. You can put them down here, you can put them up, it doesn't matter. So we just know that we have 2 ranger stations and we know that they're 5,000 meters apart, right? So that would be phase 1. Then it says the angles of observation to the fire measures 52 degrees from one station and 41 degrees from the other station. Find the distance along the line of sight to the fire from the closer of the 2 stations. So angle of observation is pretty basic for now. We're just thinking if what was the first one given to us, 52 degrees. So you'd say, okay, they're looking this way, and then they measure. So the angle of observation is to the fire from the ranger station is 50, just right, like 52 degrees like that. And the fire is somewhere out here. Maybe we put F for fire. And then the other one is at 41 degrees, so that would be looking at 41 degrees like that, angle of observation like that. We're not going to get actually into the details of is it looking north and then 52, there would be a little more exact. But angle of observation would just be making that a 52 and this a 41, that's fine. So then, that's almost a good picture for 1 point. A good thing to do is it says, find the distance along the line of sight to the fire from the closer of the 2 ranger stations. So which side are we going to be looking for? The left side or the right side in this case? The left side, right? And so writing this for D, the distance or whatever, that might yield a point. I'm not guaranteeing, but looking at that, that'd be a nice picture drawn. We've got a triangle. and then you put the unknown there. Now, one other thing that I would actually say would yield the full point, leaning towards that, is you need one more piece of information that you can add there without having it written. What's the other thing that you could find without doing any trigonometry, but could add in the picture? What's the angle measure here? 87. And you actually need that angle, right, in order to solve. So there, that's looking really good. You got a nice picture drawn, all the sides, all the angles. And then you're like, okay, now I got to do trig. What is amazing is I warn you, just like I did for the MCA, but people still do this. Should you use SOHCAHTOA? Let's start with SOHCAHTOA or Pythag. No, but people will. They'll do, sine of 41 is opposite over 5,000, d over 5,000. It makes sense because you have a triangle and SOHCAHTOA, but don't do that. It's not a right triangle, so don't do SOHCAHTOA. You just figure out law of sines or law of cosines. This is under the law of sines section, so it would make sense that we do law of sines. So we say sine of 41 over unknown d is equal to sine of 87 over 5,000, and then you just cross multiply and solve. Not too challenging there. Hopefully not too challenging. Okay. You want to just stop there and just let you work. Give you 17 minutes to work on some H-dubs. Let's do that. Okay. So we'll grade whatever 12.6, I believe, and 12.5. I don't know if we graded 12.5. Did we? Can't remember. Well, we'll grade whatever we haven't graded up through 12.6. We'll grade that tomorrow. We won't grade 12.6 tomorrow. Or 12.7, I'm sorry, we won't grade 12.7 because the sophomores were gone. So,
Yeah, we graded 5.
We did?
Yeah.
Yeah, so we'll just grade 12.6 tomorrow.
And then 12.7 will catch up.